Target D, Notes Day 1. So target D is all about compare linear and exponential function. So for number 1, congratulations. You have been offered a part-time job at the Berwyn Public Library. They will pay you a starting salary with a raise of $250 per year. Determine the model that represents your salary after T years. Okay, so this is telling us it's $250 per year. So every year it's going to be increasing $250. That represents a constant rate of change. So this one's actually going to be a linear function. Remember, linear functions are y equals mx plus b. So $250 per year, that's what's changing every year. So that's our slope. So that's actually our m value. And your starting salary is our b, because that's exactly where we would be starting in the graph. So it's going to be y equals 250x plus 10,000. And that's it, because you're only going to be creating the equation for this problem. You don't have to solve for anything. Again, some of you might like 250x plus 10,000, or you could use t for years. That's perfectly fine. Just be careful not to confuse it with your plus sign. So if you want to leave it as x, that's perfectly fine with me. I will not mark any points off. Number 2, you have just been offered a part-time job. They will pay you a starting salary of $10,000 with a 2% raise per year. Determine the model that represents your salary after T years. Remember, your clue words here is the percentage. Whenever you see a percentage, make a connection with exponential. So for exponential, remember the formula is y equals a sub 1 parentheses 1 plus or minus r to the x power. So for this one, a sub 1 would be our starting salary. And you're going to get a raise, which means we're increasing. So we're going to have to be adding to 1 instead of subtracting. So let's start the formula with y equals the 10,000 parentheses 1 plus, because it's a raise, the 2%. Remember, 2% as a decimal would be 0.02 to the x power. So again, I'm going to simplify 10,000 parentheses 1.02 to the x power. Again, you could leave it as x, or you could write t for years. I will not penalize you on that. Keep moving forward. Number 3. Which set of data is more appropriately modeled with a linear function and exponential function? So this one, remember, for linear functions, the pattern is to either add or subtract. An exponential function would be multiplications or division. So remember, that's our clue words for this one. So for table A, we're looking at the y values. How did I go from 500, 100, 24, 0.8? So first I gotta, am I adding, subtracting, multiplying, or dividing? 500 to get to 100 to 20, you're dividing by 5. If you want to do a trick for this, remember, check. I started from really high, ended up really low, which means I'm either going to be adding or subtracting. But since I'm going from high to low, I'm actually dividing. So then you got to figure out what you're dividing by. So in this one, since I'm dividing by 5, table A represents an exponential function. Table B, 17 to 40 to 63 to 86 to 109. They don't seem familiar to me as multiplication facts, so I'm going to check. Am I adding or subtracting? So to get from 17 to 40, I added 23. 40 to 63, added 23. 63 to 86, you added 23. So if we continue that pattern, we're going to keep on adding 24. Since we're adding, table B would be a linear function. Table C, I went from 500 to 401, 302, 203, 104. To get from 500 to 401, I subtracted 99. 401 minus 99 gives you 302. And if you keep following the pattern, you are subtracting 99. Since I'm subtracting, table C would be a linear function. Last table, table D, I went from 2, 4, 32, 128, 512. 2 to get to 8 would be either adding 6 or multiplying by 4. But for 8 to get to 32, you can't add 6 because 8 plus 6 would give me 14, not 32. So here, I'm actually going to be multiplying by 4. 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128. 128 times 4 is 512. Again, since I'm multiplying, this table would represent an exponential function. Number 4. So it's the same type of problems. Label each table as representing exponential growth, exponential decay, or neither. Explain how you arrive to your answer. So from 1/4 to half, if you don't know this one's kind of a little bit complicated. I'm multiplying by 2. Half times 2 would give you 1. 1 times 2 would give you 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So in this case, since I'm multiplying by 2 and it's growing, it's going to be exponential growth because you're multiplying by 2. Again, because I see the word explain, I do have to explain. Let me switch colors real quick so I don't get confused. All right, for B, I went from 64 to 16 to 4 to 1 to 1/4, 1/16, 1/64. So here I notice I'm decreasing. So I'm either subtracting or I'm dividing. However, when I see my numbers, I do not have a number that can be subtracting each time to get the numbers I am getting. So this one's actually dividing. So this one would be exponential decay because it's getting smaller, because it's dividing by 4. 16 divided by 4 is 4. 4 divided by 1 is 1. 1 divided by 4 is 1/4. Table C, I went from 0, 5, 8, 9, 8, 5, 0. If you notice, from 0 to 5 we've increased. 5 to 8 we increase. 8 to 9 we increase. However, 9 to 8 we start to decrease. 8 to 5 we decrease. 5 to 0 we decrease. So in this case, it would not be any of exponentials, just for the fact that I started increasing but then I decreased. So in this case, it's going to be neither, because you're increasing and then decreasing. It increases, but then decreases. Did not give myself enough space, but that's fine. Table D, I got 3, 0, -1, 0, 3, 8, 15. So from 3 to 0, I'm subtracting. 0 to -1, subtracting. -1 to 0, you actually added. 0 to 3, you added. 3 to 5, you add. 8 to 15, you add. So same thing like table C. This would be neither or neither, whatever you want to say it, because it decreases, but then increases. Again, whenever you notice a problem that starts to either flip-flop like that, that's an automatically indicator that it's not going to be exponential growth. It's not going to be exponential decay. It has to be consistent throughout the table. And last but not least, E. Again, we are only looking at the Y value. I went from 1/25 to 1/5 to 1 to 5 to 25 to 125 to 625. Hopefully you could recognize here that we're actually multiplying. We're multiplying by 5 each time. So this would be an exponential growth because it's multiplying by 5. So this will conclude day 1 notes. Once you complete day 1 practice, I suggest moving on to target day 2 notes.